Okay, in this video, we want to talk about hypothesis testing. And if you want to get an understanding of this, it's a pretty difficult concept, but what's really beneath it isn't so hard. It's that some of the details get confusing. So let's take a look at it and start with just the underlying concept of how it works. Suppose that you are looking for a used car and you go on to Facebook or Craigslist and you find what looks like a fantastic deal, thousands less than you would have expected to pay. So you go to this guy's house and he says, "Yeah, this is a fantastic used car. You were so lucky to be here. Other people are coming later. You have got to buy this thing. It's a great deal." So you get in the car and you start to go for a test drive. And as soon as you back out of the driveway and you start going down the street, you notice the brakes are squeaking when you come to a stop at a four-way stops intersection. So you look at him and he looks at you and says, "Yeah, the brake pads need to be replaced, but that's really inexpensive and you're still getting a super deal." So you keep driving and you start to merge onto the interstate. And as you do, you notice a little trickle of smoke coming up from the radiator. And you look at him and he smiles at you and he says, "Yeah, I know what you're thinking, but the head gasket burns a little bit of radiator coolant, but it's always been that way. It's no big deal. I just forgot to top it off. If you keep it topped, it will be fine. It's been that way forever. That's just part of the reason this is such an incredible deal." Well, then you start to merge on the highway. You get up to about 55 miles an hour, and you notice that the transmission shifts a little funny into fourth gear. And you look at him, and he looks back at you, and you say, "Well, what's up?" And he says, "This is no big deal. This is a problem with the way they manufactured this transmission. It shudders a little bit, but this is not an issue. I've had it looked at by a mechanic. He says it's perfectly fine, but it will do this." So you get back to his house, you get out of the car and walk out, and he says, "All right, are you going to buy this car? Because I got a lot of other people, and someone's buying this thing today." And so you are in that moment and you have to make a decision. Am I going to buy this used car? Well, you have to make a decision based on the only evidence you have. And the only evidence you have is the test drive. And so the way I like to illustrate this in class is like, okay, this guy's claim is here. He says this is a great car. And you're standing here with him, and then the brakes are a problem. And so you say, well, you're no longer quite as sure it's such a great car. And then the radiator starts to have that issue. So you take a step further away from him and you wonder even more if he's right. And finally, there was that problem with the transmission. So here's his claim: this is the best used car that you can buy. And he could be right. It could be that these three problems are insignificant and that this would be thousands of dollars you'd save compared to another car. But with each thing that has occurred, it's taking you further and further away from his claim. And so the only choice that you have is based on the evidence that you are presented with, your test drive. That's it. That's all you got. So you have to make a decision on that. And if you were like me, under the circumstances, I would probably walk away. Now, that's the idea behind hypothesis testing. Now, we're going to see the parts, the pieces. I'm going to explain it to you as we do one. The first thing you have to do is set up what's called the null. It's H, that's an H, not, and an alternative called HA. And it will always start with this, at least on this version. You're going to put a mu here. That means a population mean. So our story is we're interested in knowing something about all the University of Findlay students, the average score that they got on an entrance exam. So somebody says that it was 75. So just like the used car guy, there's a claim being made here. Someone is stating a cold, hard fact that 75 is what people got on that exam. Excuse me. Now, on the alternative, everything is going to repeat. Everything. The 75 repeats. Here's the cold, hard fact. We repeat it. But on this, you have three choices. You've got less than, greater than, or not equal to. And we'll do a problem at the end here, but there's usually the last sentence tells you which of the three signs it is that you're interested in. So let's just say we think that the true mean score on that entrance exam to Findlay is greater than 75. Okay, so here's called the null and alternative hypothesis. This is the cold hard fact someone says, and we think it's bigger in this case than what they said it was. It's greater. Okay, the next step is called the test statistic. And it is nothing more than a z-score. It's in a different context, so they give it a new name and call it a test statistic, but this is it. It's a z-score. That's all it is. It's, well, let me give you one here and we'll talk more about it. So suppose somebody says, like here we have our claim that 75 is the center of the curve. And this is the whole heart of the idea. If that person's right, if 75 is really the center of this curve, if it's really the truth about the test, then there is a normal curve that we could build right where he says it is. So someone says it's 75, fine. If that's what you say is the truth about the mean for everyone who took this test at the University of Findlay, then let's put it to the test. Let's put the normal curve right where you said it was. Now, I sample some people. I take this classroom, add everybody up, and divide how they did on the entrance exam, and I get X bar as 83. That's my dot. That's my sample. This is my test drive. This is the only evidence I have. And the people I asked, I get an 83. Now, if you look at this test statistic, it's a z-score. It's just comparing. So if you remember, I'm going to leave part of the story out here, but just so you see, this is a z-score. So here's what this means. My dot, my evidence, my 83, is almost 2.5 standard deviations away from the center. Now hold on. If that's true, what do you know? If he's right about the center, where are most of the dots? Aren't they in the middle? Doesn't the empirical rule tell us that 68% of all of them should be one step up and one step down? And that 95% of all the curve should be 2 steps up and 2 steps down? Isn't that what we've learned? So a z-score is I am 2.5 steps above the mean, the average score. You see, if he's right about the middle, it is very unlikely that I would have got an 83. It's very unlikely. It's not impossible. It does happen. But most of the time, if I take a sample, it should be around his 75. So he says 75 is the middle. Well, let's put a normal curve there. But if that's true, all the properties of normal curves should hold as well. And that usually, when I take a sample of people, a dot, an X bar, I should be reasonably close to him. So in our sample, I am 2.5 standard deviations away from where he says the middle is. That's pretty unlikely. And so I'm likely to think, you know what? 75 is not the middle. I could be wrong, but the only evidence I have, like I'm standing on the driveway of the guy selling the used car, the only evidence I have is that he's not right. It isn't 75. Okay, so after the test statistic, we get into something which is unfortunately confusing, called a p-value. And all the p-value is the probability of getting a sample like this, if he's right about the middle. So he says the middle's there. Well, what are the chances that I would get this dot? What your calculator is going to do for you, it's basically just doing normal CDF. It's saying, what's the probability of being here or further? Well, it's 4.53%, 0.0453, 4.53%. Well, if you think about that, that's not very good chance. So once again, we're thinking this is very unusual to get a sample like this, and we probably don't think he's right about the middle. Now, what's after the p-value is that we need to make a decision. And you've got two choices. You can reject or fail to reject. That's it. The only two choices you have, reject or fail to reject. Okay, so what do I mean by that? We are only talking about the null, the top one. That's it. We're only worried about the top. We're trying to decide whether we are rejecting or we can't reject that cold, hard fact that someone has said. We're not sure about the alternative. We don't know that. It's only about this cold, hard fact. So as we've been saying, I think this dot is too far away from the middle. So I don't think he's right. I would reject the truth, this idea that 75 is the mean on this test. And my p-value is 0.045. There's only a 4.5% chance of getting a sample like that. So I'm thinking reject. But there's one more piece to the story. Suppose this was a really important decision. And I say, well, 4% of the time to get a sample like that's really unusual. But you say, wait a minute, we can't just reject this and so quickly. It's a big deal. And so you think that 4.5 is enough to say, well, I don't want to reject that. So we add what is possibly the most confusing part, called an alpha level. It's not meant to be, but this gives people trouble. We need a cutoff line so that before we do this hypothesis test, we have decided beforehand that if we're under this alpha level, then our sample is rare. So if they don't tell you, the alpha level is 0.05. Otherwise, the problem will tell you. So memorize this. You just need to memorize this. If you are less than alpha, if your p-value is less than alpha, you are going to reject. Say it again. If your p-value is less than alpha, you are rejecting. What you're saying is getting a sample like this is too unusual, and we don't think that's really the mean. So if you're less than alpha, you reject. If you're greater than alpha, you fail to reject. So look at what we've got here. We've got 0.0453. That is less than alpha. So we memorize this at first until you get better at wrapping your head around all of it. That means we reject. Okay, we got one last piece. We want to put all of this in the context of the problem. Well, what does that mean? Don't overlook this. This is not a suggestion. This is totally, if you have any trouble with this, this is the way to do this. There's a million ways to put this in the context, and many of them are wrong. There's only a few ways to say this right. But this will work for you, I promise. Go back to the top. You only are making a decision about this one. You're either rejecting this one or not rejecting him, failing to reject him. So circle the one we decided we're going with. Okay? So we said we are rejecting him. That's what we said because we were less than the alpha. So let's circle the one that we like. We like this one. So we rejected this. It was always about this, which means we must like this one. So if you want to tell me the context, just explain to me what is in that circle. That's all you got to do. Look at that circle. So here's what we think. And always start it with the evidence suggests. This is not a fact. We do not know for absolute certainty that this is the case. There are dots out there. We could be wrong. However, the only evidence we have, like our test drive, the only evidence we have suggests that the true mean score on this entrance exam at the University of Findlay is greater than 75. That's what that circle says. Evidence suggests the true mean score on this test at the University of Findlay is greater than 75. Okay, now let's do one together. And unfortunately, which often happens, I don't have my calculator with me, but I think I remember most of the parts here, so I'm going to talk you through. Now, this is on the activity that I've given to everybody, and you're not going to do 1, 2, and 3. You're looking here. Let's work through 4 together. We're doing the rest of this activity, but we're starting with 4. So it wants me to state the appropriate null and alternative hypothesis. Oh, I forgot. I'm not going to be able to write on the screen. So, sorry, I'm thinking here. I'm going to just have to say it, I guess. So you've got H naught, like I did on the other screen. You've got H naught, the mu equals, and HA, the mu, and we're just going to leave that alone for a minute. Hold on, I'm going to pause this and bring my whiteboard. Okay, so it always starts like this. Here's step 1. We need a null and alternative hypothesis. The mu is going to equal something. So let's go back to the story. In that story, can you find the cold hard fact that somebody says is always the case when you get on Facebook? Someone is making a statement saying this is the way it is. And if you read through that story, do you see it's here? Somebody is saying that the mean time on Facebook is 20.8 minutes. They're saying that's the fact. Okay. I don't have to put the minutes on there. Let's just leave it without. Okay, somebody says it's 20.8. Now this one repeats. The only thing that changes is the sign. So let's look back there. It's usually the last sentence. A social scientist is interested to know whether the mean time of Facebook visits has increased. Okay, has increased. Isn't that greater than? Remember my choices were less than, greater than, or not equal. Isn't that greater than? It is. So we're set up. We have our null and alternative hypothesis. Now we need the test statistic. It's going to be z equals something. So let's get this off of our calculator. We've done z interval, t interval, and one prop z interval. Now it's time for a z-test. And again, I'm sorry, I'm not going to be able to give you the real numbers here because I do not have the calculator with me at home. But we want to run a z-test. So go to z-test, and you're going to see, I believe it's going to say mu naught, and you're going to put in 20.8. That's the hypothesized mean. Someone says it's 20.8. And if you go back to our story, we have everything else we need. Excuse me, don't remember the order, but here's your standard deviation. N is 100. There were 100 visits to Facebook. And X bar is 23. That's our test drive. That's our dot. We're going to see if 23 is close to the middle. If 20.8 is the middle, like they said it is, 23 should be reasonably close. So let's check it out and see how that works. I believe you get something around 2.7 on this. And so there's my test statistic. Number 3, it's going to give you the p-value. And I believe you get something like 0.034, something like that. If these are, I know may not be exactly right, but I know I'm close on both of these. So if you're following my logic, here's what we got so far. This means that if someone says the middle is 20.8, our sample was 23. Our dot is 2.7 standard deviations away from the middle. It's a very unlikely place for it to be. We should have been closer. So if you're following this, you can probably see what we're going to do is reject. But let's take it the rest of the way. So somebody says our calculator tells us the chances of having a dot there are around 3%. It told us an alpha level. Here it is. Alpha is 0.05. That's the common one anyway. So what we do, it's just memorize it if this confuses you. Are you less than 0.03 or 0.05? We are. Less than alpha means reject. And finally, we need to put it in context. It was always a statement about the top. So if we're rejecting the top, that means we must like this one. So what do we say? The evidence suggests that the mean amount of time that people spend on Facebook has gone up. That's what that circle means. The evidence suggests, it's not a fact, it's only evidence, that the mean amount of time people spend on Facebook has gone up. It's increased.